Hey guys, we're up to section 9I on pages 25 and 26 in the note packet. Again, I'm going to fill these out along the way, but you're welcome to just read the filled out notes as well. And speed me up if you need to watch the video more quickly. So in the laws of probability, what we're going to show you is something called the addition law. And the first scenario is if we have two events A and B, and they share some outcomes, then we would draw a Venn diagram with intersecting circles, and we're interested in finding the probability that event A or event B occurs. Okay, so the word or, that's an important part of understanding probability, A or B. In the sets chapter, you saw that or was associated with the union symbol. So in the laws of probability, we're going to have that the probability of A union B or A or B occur is equal to the probability of A plus the probability of B minus the probability of A intersection B. So in order to understand this, let's take a look at the Venn diagram where I'm circling event A. And then I want the probability that either A or B occur. So if I go circle event B, you'll notice that the blue circle and the red circle that I just made, we counted the b, the lowercase b, twice. So this interior part of the circle got counted twice, right in here. So when we look at the probability, we're going to sum p of A plus the p of B, and then noticing we counted the middle twice, hence we're minusing off the intersection. So that rule is called the addition rule. Now a special case of the addition rule, following along down here, is the addition law for mutually exclusive events. So in mutually exclusive events, you've previously learned that they have no outcomes in common, so their probability, the intersection probability, the probability that A and B both occur equals 0. So in this case, when we add up the probability of event A happening, all this, plus the event probability B happening, there's nothing to minus off. So we'll have the special case that the probability of A union B is just found by summing P of A plus P of B. So now how am I going to know when to use this in any particular problem? So in any particular problem, what you should notice in IB is that you're going to see problems that really don't have context. They just give a list of probabilities, and from that list of given probabilities, you have to find something. So in this case, when we use formulas in math and science, we just want to basically find ourselves following the idea that we should plug in what we know and find what's missing. So if I use this addition law to solve these problems, you'll see that this section is very straightforward. So the first sample problem here at the bottom of the page shows you that the probability of x is 0.6, y is 0.5, and x union y is 0.9. Find the probability of x intersection y. So if I write out the addition law, the main topic of the section, and use the letters x and y instead, this is what it would look like. The probability of x union y equals p of x plus p of y minus p x intersect y. So if I plug in everything I know, 0.9 for this, 0.6 for this, 0.5 for this, and I minus off what's missing, then I can easily solve for it. So I'll get negative 0.1 equals 1.1 minus px intersect y, and therefore I get, what am I doing? Sorry, back up. So 0.9 equals 1.1 minus the probability of x intersecting y. So negative 0.2 equals negative p of x intersecting y. So when we solve, we get x intersecting y simply equals 0.2. Flipping the page. A couple more problems to practice this idea. Okay, so now the stem of the question tells us A and B are mutually exclusive. When they tell me that in the problem, then I'm being told that A intersection B's probability is 0. So now, if I use the addition law again, I know I'm supposed to basically just use the special case that the probability of A union B is P of A plus P of B, because there's nothing to minus off if the intersection is 0. So let's plug in what we know, 0.8 for that. This is missing, 0.45 for this, so 0.35 equals P of A. Okay, very straightforward there again. And the final sample problem. Now I have tickets 1 to 15 placed in a hat. One's going to be pulled out at random. Let A be the event that it's greater than 11, B less than 8. So first question, are A and B mutually exclusive? Well, let's find out. So for part A, let's write out set A, number drawn is greater than 11, so that'll be 12, 13, 14, 15. And then set B, the number is less than 8, so that'll be 1 to 7. So yes, A and B are mutually exclusive. They share no outcomes. All right, so then part B, if we find these probabilities, P of A is a simple concept. There are 4 outcomes out of the 15 in the sample space. P of B has 7 outcomes in the 15 in the sample space. And the probability of A union B, because I said yes to mutually exclusive, it's just PA plus PB. We're using a special case. So 4 over 15 plus 7 over 15 makes 11 over 15. Okay, hopefully you found that straightforward. That's section 9I.